So here they are asking us to find a polynomial given zeros, and they're giving us the zeros in terms of multiplicity. So don't let that throw you off. Multiplicity just means that that zero is repeating itself more than once, right? So we see here that -1 has a multiplicity of 2. So right away I'm going to rewrite that. I'm going to say that x plus 1 is to the power of 2. And that's all that multiplicity of 2 is going to look like, right? And then the next one says -2 minus I has a multiplicity of 1. So there it's telling me that it only repeats once, which is kind of nice, right? So x minus, and then in parentheses, -2 minus I. Now, remember that whenever we have that I, we always have to have the positive part of it. So even though the multiplicity is 1, that means that we still have that other guy, right? So x minus -2 plus I. Okay, so there are our zeros plugged back into binomials, and now we can actually FOIL things out, right? So this x plus 1 to the power of 2, well, that just means that I have x plus 1 times x plus 1, right? Because it's to the power of 2, that means there's 2 of them. So we're just going to distribute that out. So x squared plus x plus 1, right? So these two actually can come together, and that would give us x squared plus 2x plus 1. So let's say if it was to the multiplicity of 3, right? So then you would have 3 of those x plus 1s, and then you would have to distribute all 3 of them. Or if it was to the multiplicity of 4, then you would have 4 of them, and so on and so forth, okay? So now let's distribute the I binomials, right? So let's do the -2 minus I and the -2 plus I real quick over here. Okay, so -2 minus I times -2 plus I. Distribute that would give me 4 minus 2I plus 2I minus I squared. Right? So these i's cancel out, and then of course we remember that I squared is actually -1, right? So this is actually -1. So that would simplify to 4 plus 1, right? Because this minus sign with the negative would become positive, which equals 5. Okay? So now, x times x is, let me rewrite this real quick over here. -2 minus I, x minus -2 plus I. Alright, so x squared minus x minus 2 plus I, right? And then minus x 2 minus I, right? And then plus that 5 that we have already found before. Right, so now we can distribute the x's in, and we get x squared plus 2x minus xi plus 2x plus xi plus 5, right? So let's see if we can cancel anything else out. And yay, these i's cancel out, right? So now we have this wonderful binomial of x squared plus 4x plus 5. And this actually still needs to be distributed out with this guy over here, right? So let's do that next. Okay, so x and x squared will give me x to the 4th power. X squared plus 2x plus 2x to the 3rd power plus x squared. 4x times x squared is going to be 4x to the 3rd. Against 1, 4x. And then you have the 5. X squared plus 10x plus 5, right? So now let's see if we have any like terms. So the x to the 4th is by itself, right? So let's do this in a different color. So f of x is going to be equal to x to the 4th power. Here's my x to the 3rd, x to the 3rd, right? So that would be plus 6x to the 3rd. Then the power of 2's, right? So x squared, 5x squared will give me plus 6x to the 2nd. And then we have our x's, right? So that would give me plus 14x, and finally plus 5. So there is our wonderful function. And sorry, it kind of went into the pencil there.